Good day to you. I'm very privileged to be here today to come and present to you our solution, FactorySmart. FactorySmart is a process that developed over the past 20 years. And in COVID, actually, we coined FactorySmart as to come to a point where we can assist you, the manufacturer, to optimize and to automate. So it's your solution towards increasing factory revenue, business efficiency, and reducing waste. And those of you that know, this is actually to look at how we can implement lean into your organization. Herewith we have our manufacturing process, and there you'll see that we start from the design, and then we also have a nitrogen generator that we can supply to you. We have visual factory automation software and also visual screens. With factory machinery, and with that we have press brakes, cleaning and grinding machinery. We have the solution where we have a partner in Cape Town where we do robotic welding, and also we do manual laser welding, as well as cleaning of the welding thereafter. In any process, when you start in a factory, you need to get a design that you need to cut or to bend or to weld. And in many instances, your designer will have to spend a lot of time having to draw parts that your customer might bring to you. And this has been a major issue for many of our customers. And we came up with the following solution. We call it trace cut. So in this scenario, we would have a part that the customer would bring to you, and you need to be able then to reproduce this part. So for a designer to take this specific part and design it would take him most probably 15 or 20 minutes. So our solution would be where we attach a computer onto an electronic board, trace this part onto a piece of paper, and then trace that with a stylus in the following format. So within a matter of 2 minutes, we can draw a part freehand, as you can see, and generate a DXF file to be able to then cut that on the machine. So the next process would be where we say, how can we implement a visual factory automation process flow in your organization? And there we have a solution with factory software where we will use Cyberfab software powered by Microstep to be able to give you visual factory automation in the following format.
Welcome to the future of manufacturing, where cutting-edge technology meets efficiency and seamless production is the name of the game. Introducing the FactorySmart Visual Manufacturing Process Flow, powered by Cyberfab software. Cyberfab software seamlessly interfaces with virtually any ERP system, ensuring a smooth and unified experience. Orders placed in your ERP system are instantly visible in the Cyberfab software, streamlining your order processing and management. Cyberfab's warehousing functionality makes it easy to allocate raw materials to planned jobs as they are received into stock. Each workstation is equipped with a visual interface screen, providing operators with real-time information and updates. Jobs can quickly be assigned to workstations for individuals, optimizing workflow and efficiency. Raw materials are placed on pallets identified by unique numbers, colors or RFID tags and
So in this process where we say we are looking at pallets, it is crucial that no material touches the factory floor. Therefore, we need to put this onto pallets, obviously if the size allows it, but more importantly, that we add wheels to the bottom of the pallets. Why? We do not want forklifts or overhead cranes to be the problem in the flow. Many times I have seen that when you're in a factory that operators are waiting for material to be moved with a forklift or with an overhead crane. This leads to excessive waiting periods of half an hour, and then your process stops right there. Also on these pallets, we can add RFID tags that once you move a pallet through a certain area, it recognizes that this pallet is in a certain area. How many times have you had to go and look and search for parts that are just missing? They were just here right now and now they're missing. So this will also eliminate the waste of waiting for these parts to be taken to the next station.
Transported to their designated workstations. Operators access the latest drawings and instructions for their jobs, ensuring accurate and efficient production.
So, the crucial part with reference to having your jobs on a visual screen is that your operator can now have a look real time on the actual drawing of how he has to manufacture it. He can even zoom into that drawing and see how this is all fit together. He does not need any additional assistance. You also see right now that on the screen you can start a job and you can stop a job. That will give you the time it took for that operation to be done.
Job is completed, the operator simply presses the completed button. Completed parts are packed and transported to the next station or positioned in the production line according to the routing order.
So it's crucial that you have somebody that takes those parts to the next station. You do not want to have your boilermaker or your welder to go and fetch parts for the next job. It wastes a lot of time as you are paying him a lot of money. So you need somebody to take the parts to the next station.
Each workstation features a colored flag system to quickly communicate the state of production. Red for immediate assistance, yellow for material requirements, green for smooth production, and blue for material shortages.
This is a crucial part that you need to implement today in your factory environment. The flagging system can either be visually, like on the screens, or before you even start with software, you need to do this on a manual basis. So give every operator in your factory 5 visual flags in their hands. Red, yellow, green, blue, brown. And I'll explain what these are for. Red means this operator cannot continue with his work. Either his machine is standing or he's got a major problem. You need to go and assist him straight away. He must not leave his workstation and look for assistance. Otherwise, he starts to talk to everybody on the floor and keeps them away from what they're supposed to do. Yellow means I am in production, I'm busy working, but I need assistance. That means I need, for argument's sake, the next batch of raw material, or I need a tool to be able to continue with my work. Green means I'm on the go. Do not disturb me. You're going to cause trouble if you disturb me. Blue means it's twofold. Either it's I'm finished with my job, therefore you can use me to go and do another job. And this means do not take a guy in the green phase and ask him to go and assist you in another process, as you will stop the flow of what he's busy with. Or blue means I'm standing because I don't have raw material. And brown, I am on the toilet.
The FactorySmart visual manufacturing process offers numerous benefits for owners and management, such as real-time traceability, accurate forecasting, cost visibility, bottleneck identification, and more. Ultimately, this system leads to improved production quality, customer satisfaction, and bottom-line profitability. Embrace the future of manufacturing with the FactorySmart visual manufacturing process flow. To learn more about how Cyberfab can revolutionize your production process, visit our website or contact us today.
Our next process is our factory machinery. And there we have various suppliers that we have partnered with. Firstly, obviously, Microstep as our flagship supplier since 2006. This is where we can offer a lot of solutions regarding optimization and automation. Secondly, we have SLTL. SLTL is a supplier from India, and they actually industrialized fiber laser. Najesa is a company from Spain, and they assist us with press brakes and with a lot of different machinery as well. Bentmac, we will be able to supply with roll bending machines. Arku is where once parts have been cut on a plasma, for argument's sake, we can grind away the dross. And Robotic Handling Systems is one of our JV partners in Cape Town that we do robotic handling with, or robotic welding. Desktop Metal is a company that we partner with to do 3D metal printing. And then obviously Hypertherm are our suppliers for plasma sources, an American-based company, and Kielberg is our German-based company for plasma sources, and then IPG, which is the Rolls-Royce regarding fiber laser sources. But right now I'm going to come and speak to you about Microstep. Microstep, South Africa, we formed this in 2014 together with my partners in Slovakia. And you would see there's Dr. Alexander Varga in the middle. He was a professor at the University of Bratislava, and he has a doctorate in mechanical engineering. And he put a few friends around himself to start Microstep in 1991 after the wall fell. It's only then when they obviously could start companies. Eva Stajskalova, right next to him, has also pioneered the software of Microstep. Together with her and Alex Makuch, they are the MDs right now at Microstep Slovakia. The bottom right is Microstep head office. That's in Bratislava, and Bratislava evidently is 60 kilometers away from Vienna in Austria. This is our team. And I'd like to point out at this stage, Kobus with the glasses, the short guy there, has been working together with me in this environment for the past 22 years. So people for us are crucial. We come to you and want to help you and assist you to grow your company. Andrei Sobolich, second from left, he knows Microstep like the back of his hand. He is from Slovakia and has also 21 years of experience with Microstep machines, and is working for us for the past 16 years as well. So this is part of our team, and I'm proud to present them to you as well. So Microstep, we supply the following technologies: fiber laser, plasma, water jet, oxy-fuel, and overhead routers. And we're the only supplier in the South African market, Southern African market, that has all these technologies, and we use the same software. So from that perspective, once you have one of our machines, be it laser or plasma, you can then get the next one, which is an oxy-fuel, with the same software. Part of our customers that you can see down here, only a few of them which we support on a daily basis. And now we go to the cutting process. Do you still remember, or are you still manufacturing or producing parts by hand? Flame cutting or hand plasma, or grinding, or a shear? Yeah, I know the shear obviously in many instances is not part of the process any longer, but that's where we started. And here we have fiber laser from Microstep, and we are one of the few companies in the world that can supply big format machines. We have evidently installed a machine in Germany that is 40 meters long by 3 meters wide, and which sets us apart from all the opposition is that we are able, on all of our technologies, being laser, plasma, water jet, and oxy-fuel, to be able to cut 2D flat sheet cutting. On the same machine, we can do 3D bevel cutting, and then on the same machine, we can add a tapping, drilling, and countersinking head, and cut tubes and profiles. So here we have the mock-up of a fiber laser cutting machine from Microstep, and you will see that we have different features. We have a dual pallet changer. Then we have also a tube cutting solution. We are the only ones that I know of currently that on a standard machine are able to cut up to 500 millimeter in diameter. Then we have a control screen. So here we have the presentation of the machine. In this instance, we have a bevel head, a tapping and drilling head, and a scanning head, and then cleaning station. An automatic patented calibration station for the bevel head. So now we come to the physical machine itself, and we'll show you how we are able on the same machine to be able to drill. This with the spiral drill that we are drilling currently. And then we'll index on the automatic tool changer. And we will tap. And there's a clamp that applies pressure that the plate cannot move when we are tapping or drilling. And this is how the part would look like. The idea for this is that we can finish the whole part on the machine. Next, we will present to you the bevel cutting functionality of the MSF. We can bevel cut up to 50 degrees bevel for well preps and for chamfers. You'll see that the piercing is also intuitively. And as the machine moves around the corners, it is seamlessly. All of this gets done via the programming that is offline. Next, we will be showing you how the machine is able to cut round, rectangular, and square. And then, very excitingly, we have a technology called ABP, Additional Bevel Process, where a part that has already been cut 2D, we will scan it. Scanning is for identifying that that's the part that we want to cut the bevel afterwards, or do reverse engineering. This is used for the following reason, that we do not want to cut into virgin material when we are doing bevel cutting. And in so doing, we save a lot of raw material, and that is the highest cost in the cutting environment. In this case, you will see that the machine is tracking the cutting curve even without the laser being on. And next, we will then cut physically the chamfer. And as you see, the corners that are being cut is very neat, and the dynamic movement of the head is phenomenal. So the next process that we have is water jet cutting. Water jet cutting, the reason for water jet cutting is that on this machine, you're basically, or this technology, you can cut materials like ferrous and non-ferrous steels, granite, glass, wood, ceramics, and many more. Obviously, we can also do 2D cutting, 3D cutting, tapping and drilling and countersinking, and tube cutting on a water jet. The usage for water jet is in combination also with plasma. We can also add a plasma head on this machine. And the advantage thereof is that edges that do not need the precision of water jet, you can then cut with plasma. And then holes that you do not want heat affected zone, you can then cut on the water jet. This gets programmed via your software that will determine whether you'll be cutting with plasma or with water jet. Water jet overall is a brilliant technology, but in the steel industry, it's a slow process. Therefore, when you choose a water jet, you need to know what your end result needs to be, and you're gladly then able to contact us further on so that we can assist you going forward. Then next is flame cutting. There are not many companies currently supplying flame cutting machines. I'm proud to present to you that we are most probably the only company in Southern Africa that can supply you with a flame cutting head that has a bevel functionality of up to 60 degrees bevel and a cutting length of 150 millimeters. So where would you use this? You would use oxyfuel cutting technology for bevel cutting, especially in the dragline manufacturing industry, or in the bucket manufacturing or repairing industry for the mining. I'm going to show you then now a video with reference to the technology and explain it according to that as well. Here we have a part that is 90 millimeters thick, and we will show you how the additional beveling process actually works in this regard. So this part has been scanned, and then we have an automatic torch ignition with also automatic height sensing. And this is how the process then would start. Heat up, and then you would start piercing and follow then the cutting process. Just have a look at the cutting quality on this part. One will not say this was flame cut. Normally with flame cutting, we have a lot of dross that gets formed and needs to be grinded. Normally flame cutting, we have a lot of dross that is formed and needs to be ground with a grinder. In this case, I want to show you the quality of cut on the radiuses as follows. The dross is easily removed without a grinder, just with the tapping of a screwdriver. This part is now turned over I mean, and then it's scanned, and the next bevel or the K cut is cut on the other side. And without a lot of effort, this part has been completed in a record time. Next in line is our state-of-the-art plasma cutting format. The size of plasma cutting for us is not a problem. I mean, we can cut up to 100, we can manufacture the machines in lengths of 100 meters and even up to 25 meters in width. The gantries are dual driven via AC drive motors, and we use linear guides on either side of the machine via a helical rack and pinion system. The rapid traverse on our gantries are 50 meters per minute, and the maximum cutting speed of the gantry is 15 meters a minute. We would never need to cut more than 5.5 meters per minute on these gantries. The positioning accuracy on the gantries mechanically is 0.05. The repeatability is 0.025. Therefore, we are able to give you a tolerance on plasma cut parts of 0.5 of a millimeter. We use the plasma arc for the high control. Now we go to the step and say, how did we do bevel cutting in the past? We used to use quickies like on the left-hand side, or grinders, or mechanical beveling. This took a lot of time and was not accurate, and was a problem for us in the industry and cost a lot of money. We present to you the 3D bevel cutting head from Microstep on the plasma in this instance. There we have an integrated calibration station that you are able to calibrate your 3D bevel head within 7 minutes should you have bumped the head. Should you not have this calibration station, our trained service engineers would take up to 5 hours to calibrate this head. I'm going to show you next how we do additional bevel cutting with our plasma cutting head itself. So next we will show you the additional beveling process with plasma technology. This part that you will see right now is 80 millimeters thick, and we want to move from this to this beveled section. How do we do this? Firstly, once every 2 months, we will then do the calibration of the laser scanner as such. And then we will move to the part that we want to cut the bevel on. We have the 2 and 3D part DXF on the computer. We search for the 3D bevel DXF as follows. This is it. We'll load it. And then on the right hand side, the screen would open up, which is the camera. Next, what happens is the operator will then place the part on the table wherever he wants to. The operator would then go and then give it 2 point references. Once that is done, automatically the machine will start scanning the part as to identify the part so that we can cut the bevel afterwards or do reverse engineering. Now the machine will do an initial height sensing because the slats could be worn and the part could be lying unevenly. We want the bevel cut to be obviously equally all around. The beauty part of this is without the plasma arc being on, we can actually track the cutting curve. And once that is done, we will start cutting. And once we get to the end of the cut, we will see how the quality looks like. And once again, this part is neat and done in record time and is reproducible every single time without a lot of effort. Do you still remember how we used to do tapping and drilling and countersinking by hand? And this operation normally gets done by trained artisans or boilermakers. We come with a solution where on the same machine we are able to fit a tapping and drilling head, and even in this instance, milling. There we have a double gantry machine that is equipped with a milling feature, as you can see in the screen right now. So we are able to cut on one machine, on the same machine, cut, mill, countersink, and tap on the same machine, as you can see right now. We have copper pins that we would place the plate on so that we can have a level plate before we do the milling, the pocket milling, as you see the part in front of you. So on the standard machine, we have a head that can do tapping, drilling, and countersinking. And how do we do this process? We have an automatic tool changer that you would program to pick up the correct tool. In this instance, we're going to drill. There we have a clamp that applies a ton of pressure that the part cannot move. We have an insert drill with spray mist. And this 10 millimeter plate has been drilled in that record time. Then we do a tool change. And we do countersinking. Spray mist once again. Once that is completed, we do a tool change and we do tapping. After this process, you will then now cut the part, and you then know how long it took to cut this part, tap it, drill it, and countersink. And repeatedly, you have the same time for hundreds of parts to manufacture for your customer. Then a very interesting solution is how we are able to cut wear plates, the countersunk holes for wear plates. We are one of the only companies in the world that are able to cut with plasma the bevel holes or the countersunk holes for wear plates. This is a massive industry and saves a lot of money. Normally, how this process would be done, you would first cut out the perimeter of this plate and then take it to a milling machine, heat up the area where you want to cut the hole. Then you would, on the milling machine, place the plate onto the milling machine and then countersink and drill the hole. The industry standard price right now is between 50 to 80 Rand per hole. In our instance, this hole, countersink hole, will not cost you 2 Rand. Typically, we're doing just the height sensing on the plate to find the levelness of the plate itself. The plasma will pierce, and you will see that the torch lead does not get entangled as it is infinitely rotational. Once the bevel has been cut, then we cut the perimeter. And what is interestingly to note is that there is normally a nib that needs to be cut into the bevel section. And you will see once we finish with the cut right now that this nib has also already been cut into the bevel section. And to point out once again, that hole will not cost you R2 to manufacture. Do you still remember how you used to use Boilermakers, or even yourself in this process, to mark plates? So to measure and mark, and the time it took to do this tedious work. We have a solution that with the same plasma head that you are cutting, you can also plasma etch mark your parts. This obviously is for part identification, or how you are able to put parts together or sub-assemblies together. We can plasma etch mark and punch. And this process is fast and readable. This process you are not able to use when you want to do identification after painting, obviously. This is just for an assembly process that this would be used. Other than that, we have a micro punch marking unit that we can supply also to be able to mark parts with an indentation of up to 1 millimeter. This process is quite fast, as you can see. After the marking, you then will be able to cut the part as well. Here we are punching the plate as well. Then very excitingly, we have another solution where we are able, on one machine, to cut flat sheet, pipe, and open sections like angle iron or channel or I-beams, which has always been an issue where people had to do this, with mag braces or flame cutting torches by hand or grinders. We have a solution as follows. We have one machine where we can do flat sheet cutting as follows. And then on the same, also bevel cutting. And then we move over to pipe cutting. There we are currently cutting, marking the part on the pipe itself for identification. As you can see, the torch is moving intuitively and changing direction as we are cutting holes. And even as you can see, it actually goes right up to 180 degrees without the chuck moving, therefore for allowing for a wide variety of cutting processes. And this you can use in the architectural industry and for structures or whatever it might be. And at the end, we'd also do weld preparation, that you do not have to do this with a grinder at all. So when you take the pipe out, it is ready for assembly. Also on the same machine, we are able to cut I-beams. An I-beam is a challenge to cut in the sense that the web and the flanges are never in the same place. That red line there that you see is a laser scanner that would sense and see how and where the web is with reference to the flanges, and it would identify whether you've got the right I-beam or part loaded. If it's wrong, you will not be able to cut that, and you have to then load the right part that was programmed. On this process, we are able, for an I-beam or for a channel, to cut to length, to cut at an angle, to cut a bevel on the angle, to cut holes and slots, and we can even castellate a beam also in this process, or even cope. That means where the two I-beams fit into each other and mark. There are very few systems in the world that are able to cut I-beams, channels, pipes, and flat sheet all on one machine. This is an exciting solution, and we have sold numerous of these machines in the South African market. The next technology I'd like to show you is how to cut a T-piece. Now, we all know how long it takes to cut a T-piece or to manufacture a T-piece. I have spoken to some Boilermakers, and they have said to me it takes them up to 2 hours to do a 300 OD T-piece. And have a look at what this solution can offer you. In this case, we have a tube cutting device next to the flat sheet cutting device, and we now have loaded a 300 millimeter pipe into the tube cutting section, and we then start cutting the T-piece. The T-piece was programmed in our software, and we've got macros where you would just then enter the dimensions of your pipe, and then intuitively it will start cutting. So mark now, we are nearly at the end of the cut. And you will see that it only takes 3 minutes and 42 seconds to cut this T-piece, and it's ready for welding, meaning the weld preps have already been cut into this T-piece. Only 3 minutes and 42 seconds as opposed to 2 hours. Absolutely brilliant solution. Our next solution is where we are able to cut dish dents. Dish dents, up to now, one needed to have a very qualified Boilermaker to be able to measure out the holes that he has to cut into the dish dent itself. We have a customer down in Cape Town that bought from us a machine that can cut up to 3 meters in diameter dish dents. Prior to him installing this machine, they were doing only 2 dish dents per day. Now, after installing this machine, they are able to do more than 12 dish dents a day. Just think on the increase in production for this company. One other feature that is quite important for us for backup is called remote diagnostics. We are able to log into your system 24/7 if you have a problem on your machine, and remotely via TeamViewer we can assist you to either fix the problem or identify what the problem is. If it's a board that you would need or whatever it might be, we will know by just running the diagnostics on your system what is the problem. So you will not have to wait for us to get to you, identify the problem, and then get the part sent over and your machine standing for another day. So for us, it's quite crucial that you are able to be up and running as fast as possible. Our normal turnaround time with remote diagnostics is the following. it's about 70% of the problems that are reported by customers we repair via remote diagnostics or with our phones that our trained service engineers will assist you by. We keep also the whole range of our consumables for Kielberg, for Hypertherm, for KMT, and also for IPG. We can assist you that you are operational at all times. Spare parts for us are quite important. We need you, our customer, to be operational at all times, and therefore we have a large inventory of spare parts that we keep in South Africa. If we do not have a spare part for any given reason, we would fly that spare part in from our suppliers. We offer you a 1-year warranty or 2,000 hours, whichever comes first. At this stage, I would like to say that we have more than 115 machines in the marketplace in South Africa or Southern Africa, and are proud to say that many of our customers are very satisfied with the service that we are offering them. Once you buy a machine from us, we will come and assist you and explain to you the power requirements that you need. You would need, obviously, a compressor that supplies the right amount of pressure and CFM, and we advise you to always install a decadent dryer and the gas installation, which we will help you with to identify as well the suppliers for that. Once we install your machine, your floor needs to be 150 or 200 millimeter thick, 35 MPa strength, and over the total length of what the machine will be installed, it needs to be less than 50 millimeter in level all over. Next, I'd like to speak to you about our supplier SLTL from India. These are our baseline fiber laser suppliers, and they were the company that actually industrialized fiber laser. Many years ago, they approached IPG, which at that stage was supplying fiber optics into the telecoms industry. They then spoke to IPG and asked them to supply them a fiber laser source that they would like to put onto a gantry machine for cutting, which they did, and therefore SLTL industrialized fiber laser cutting. We are proud to associate with them and have supplied numerous machines into South Africa. I can gladly say that the service level that we receive from SLTL is phenomenal. I'm able to send a WhatsApp right now, and within 15 minutes, I will have an answer from my partner at SLTL. I'm going to present to you now the flat sheet cutting machine from SLTL. So this is the Infinity model. They have a few models, but we sell many of the Infinity model. And there we have the option for a flatbed cutting machine and also the tube cutter on the side. There's a pallet changer, which is crucial, and any machine that we will supply into the Southern African market, we will not supply without an enclosure, as the laser reflection could blind people. Therefore, we will not sell machines without the enclosure. Here you'll see that this machine is moving quite fast in the cutting process. And next, we are also able with SLTL to do fly piercing as follows. As you see there right now, it seems like nothing is happening, but what's actually happening there right now is that on the fly, without the machine standing still and piercing a hole, we are cutting a sort of a grit, as you can see right now, which is phenomenal. So SLTL as a supplier is really an amazing company that I have visited, and I'm very proud to say that I'm happy with their quality, as opposed to where we find many suppliers currently in our market that are not reliant and not giving service backup. Next, I'd like to introduce to you the tube cutting solution from SLTL, which is a standalone machine. As I've said prior, we have the solution for a flatbed and tube cutting in one, and freestanding tube cutting as follows. Here you'll see a modular system where we are able to cut round, rectangular, square, flat, angle, and channel. Very versatile and very excited to present this to you. Can we go? So next I'd like to discuss with you press brakes, and there we have a brilliant supplier by the name of Najesa from Spain, and there we have a few solutions like press brakes, shears, non-mandrel pipe benders, horizontal press brake, and more. I'm glad to present to you Najesa, and then the Najesa press brake as follows. Najesa have more than 400 machines in stock at all times, and the intuitiveness of these machines are phenomenal. As on the press brake, I'd like to show you the ease of programming.
Carry out this folding. Sort of barrier the press brake has. This up and down. The CNC control of the machine is the one responsible for running these axes. To program a new part, we select New Program, New Graphic, and insert the material information, width, thickness, type of material, die and punch that we will use, as well as the punch alignment. We accept. Then we proceed to draw the geometry of the piece.
So you are able to draw a part on the screen of the press brake or on the computer in the office.
The drawing is finished. We select the first selection using the red arrow and enter its size in the field, L, 20 millimeter. We validate by pressing the Enter key and continue inserting all the dimensions of the piece. With the program finished, we click Calculate and Optimize. The CNC indicates that you have found a solution and shows us the process. We activate the automatic mode to start the sequence. The CNC indicates the specific position in which we must place the material in the folding area.
Next, I'd like to show you the non-mandrel pipe bender and its functionalities. So once again, non-manual pipe bender for round, rectangular and square. And it also has a chuck at the back to facilitate 3D bending. To facilitate 3-axis bending. Our next exciting solution is robotic welding. There we have taken hands to robotic handling systems from Cape Town, and we were able to supply a solution to Namakwa Engineering 8.5 years ago. And this was for the SKA project, the Square Kilometre Array project, where Namakwa Engineering had to build 21-meter diameter substructures for the scottles with a tolerance of 1 millimeter. And the only way how they would be able to do this, Stockies said to me he wants to have robots, which we then were able to help him with. He would see that the robot is picking up a part. It's got a camera on a light table that's been placed this part. It would identify it and pick it up and then place that onto a table as such. The robot would go back, identify the next part, pick that up, and again, this was done already 8.5 years ago, and this is in South Africa, not Europe or America, South Africa. Pick up that part and place it exactly in the slot. The robot would come and tack it together. Again, tolerance of that 21-meter diameter was 1 millimeter, which Stockies was able to achieve. Next, we have an amazing process that takes place. A third robot comes into position, picks up that part, while the other robot identifies the next item, picks that up, and the third robot holds that part like a human being, and it gets slot in and gets welded. This all was done together with Namakwa Engineering and our partner in Cape Town, Robotic Handling Systems. So we are able to assist you with any robotic handling systems or welding, be it on MIG, TIG, or even laser. In this scenario, we have a software called Delphoy. Delphoy software will enable you to program a part for robotic welding. Instead of taking 4 days, this will enable it to be done in 4 hours. The biggest challenge with robotic welding is that in the past, you would only be able to weld parts that have been jigged. In other words, where the gap was smaller than 0.6 of a millimeter. And that was a major problem for being able to weld parts with robots, and very costly. Now, with the entrance of servo robot tracking systems, we are able to scan the gap from no gap up to 10 millimeters. We are able to weld. And what happens is, as it scans, it will identify the gap and translate the gap to the robot. So as the gap increases, the speed of the robot would reduce and it would feed more wire automatically. And if the gap becomes too big, it will then start weaving. We are able to supply robotic welding systems even if your gap is bigger than 0.6 of a millimeter. The other issue that we have in South Africa is load shedding. Therefore, we've come to the realization that we need to also be able to facilitate the installation of solar power. We have taken hands with Sun-spec Solar, and once you have a need for continuous power, you can speak to us and we'll be able to connect you with Sun-spec Power that will come and do your due diligence on your energy needs and supply you with a solar power solution. The most exciting technology at the present moment that we are offering is manual fiber laser welding. This is taking the industry by storm, and we have sold a few units already in South Africa. We are set up to assist you both on sales and service backup. What we have here is a system that is able to weld mild steel, stainless steel, aluminium, and copper. And we can also weld dissimilar materials, meaning we can weld stainless steel onto mild steel. We can weld galvanized onto mild steel. So we are able to come to your premises and to give you presentations with reference to the different welding jobs that you have to do. Once you have welded stainless steel, you always have a heat affected zone on the weld itself. We therefore are pleased to present to you the Micro Clean machine manufactured in South Africa, and which we have already supplied a few in the marketplace.